What are some disturbing facts about space? Story 1. If you gathered together all the matter in the universe we can observe right now and squashed it together until it had the density of water, it would fit into a cube about 1 light year on each side. There are several disturbing things about this. 1. A single light year is almost unimaginably huge. 2. A cubic light year is a ridiculous volume of space. 3. The observable universe is 33 orders of magnitude larger than that. 4. It's almost entirely empty. A couple years ago, I saw a photo that had been taken from the surface of an asteroid or comet. It was dark and looked like there had been some sort of artificial light illuminated to take the photo. I thought to myself that may be what hell is like. No light, no sound, no stimuli of any kind. You're not really able to move of your own volition because with nothing to push against, you just aimlessly float. And that is eternity, nothingness for eons and ages, while your consciousness ticks along. Story 2. How easy it would be to become completely and totally isolated out there. In space, technology is the only thing keeping us alive. The only reason we don't freeze, suffocate, or starve. When something like a car breaks down, we can call a tow truck and get it repaired. In space, there's no such thing. Think about Apollo 13 and everything that went wrong there. Imagine the day when humans advanced to traveling deeper into space. With noteworthy landmarks being so far apart, navigating without a computer would be almost impossible, even if you still had communication with Earth. Imagine not having communication, completely alone in the blackness of space. Or even worse, your engines die and you're just forced to sit, hoping and praying that somewhere in the vast universe, someone comes across you. That is far scarier than any movie monster. Story 3. Here's one closer to home. The Kessler effect is the theory that a single destructive event in low Earth orbit could create a cascade where satellites break up into tiny fragments, taking out other satellites, breaking up into smaller fragments, and so on, until the Earth is completely surrounded by a massive cloud of tiny flying death shrapnel, which would make leaving this planet almost impossible. If you look up how much space debris is already up there and how many satellites currently orbit, plus the continued growth of the commercial space industry, I think about it a lot. Story 4. Rogue planets. Such objects have been ejected from the planetary system in which they were formed, or have never been gravitationally bound to any star or brown dwarf. If a rogue planet invades our solar system, things could go very wrong. Rogue planets are cool. I like to think about rogue planets and supervoids. Imagine a catastrophe that hurls a planet into space. The civilization is of course wiped out, and the planet floats for millions of years into the void, where it becomes a cold, dead world, with the ruins of a civilization floating in absolute darkness. Story 5. Sometimes the scariest thing that professional astronomers can experience is something that they don't see. In 2019, scientists at the Royal Institution of Australia, along with NASA and other international space agencies, completely missed a football field-sized asteroid that came eerily close to Earth's atmosphere and had apparently realized it only minutes before it passed Earth. An asteroid called 2019 OK, traveling at almost 15 miles a second, came unusually close to impacting Earth. It passed by about 43,500 miles away. The asteroid came much closer to Earth than our moon, roughly 1/5 the average distance from Earth to the moon. Michael Brown of Monash University noted that it was the largest asteroid to pass this close to Earth in quite a number of years. Asteroids of this size are capable of triggering the equivalent of a large nuclear explosion if they hit Earth. Swinburne University astronomer Alan Duffy mentioned that this particular asteroid would have struck the impact area with over 30 times the energy of Hiroshima's atomic blast. So how and why did some of the brightest minds on the planet miss this potentially destructive asteroid until just before it jumped past us? There are several reasons. 1. The asteroid had an unpredictable eccentric orbit and speed, and this made it challenging to spot it ahead of time. 2. The asteroid was coming in from the direction of the sun, adding even more to the difficulty of scientists zeroing in on it. 3. The asteroid was, morbidly considered, not big enough to be labeled as dangerous by space agency computers and telescopes. For the record, impact events big enough to kill off the dinosaurs require an asteroid that is at least half a mile in diameter. Space agencies have charted and identified 90% of asteroids orbiting in our solar system and know their location at any given time. Any asteroids smaller than those are not considered important enough to mind and manage as a result. Bonus. By the way, the very next year in 2020, an even larger asteroid passed in between Earth and the Moon. Astronomers using the Atlas telescope in Hawaii discovered an asteroid named 2020 LD had shot between us and the Moon 2 whole days after it happened. So yes, these sorts of things do occur a little more than we'd like. Story 6. There is a theory, proton decay, that states that protons, one of the fundamental building blocks of matter, can just spontaneously evaporate. The amount of time this takes is astronomical, but current theories predict that all matter in the universe will decay away until there is nothing left but particles of light and empty space. The time it will take for this to happen is incomprehensible, but it is the most likely scenario for how our universe will end. Story 7. The number of solar flares that have missed Earth by a thread are astoundingly disturbing. There was one solar storm back in 2012 that missed Earth by 9 days. 9 flipping days. If it had hit, we would have lost all forms of electricity and not been able to recover for 4 years, and that would have been the least of our worries. Story 8. The Great Attractor. More frustrating not knowing that disturbing. Fermi paradox. So alone. Singularities undermine mathematics and logic. Heat death or big rip. Eventually we die. Time. So much time. We are a flash in endless darkness. The sheer size of even the observable universe. We are nothing. There is no absolute position or time. Where are we? The governing force seems to be entropy. Oh yes. You boil when exposed to the vacuum. Story 9. Here's one. It is a completely one-sided relationship over which we have no control. We, as an entire planet, represent zero threat to space. There is literally nothing bad we can do to it. However, at any moment, one of a zillion horrible things, most of which we can't even imagine, could completely wipe us out. And in the long run, we know that will happen eventually, no matter what we do. Even if we live out our sci-fi fantasies of someday finding a habitable world, by the time that happens, any potential new homeworld will be so far away that our spacecraft would rot away before we ever got there. Space is infinite, and we have no hope to be. Story 10. I think it's pretty scary that nobody, alien species, has encountered us yet. There are a few theories about why this is, but the scariest one is this. It is possible there is an alien race that is obsessed with destroying intelligent worlds. Marvel fans, think Galactus. Once an intelligent world starts picking up enough dust, sending radio messages into space, or exploring new galaxies, the alien race will notice them and destroy them. It's possible that we're so unadvanced that we don't even show up on the map for a world-eating race of aliens. The 3 Body Problem books deal with the Dark Forest model pretty extensively. It doesn't even have to be one species that wipes out others. Basically, no species can ever trust others to be benevolent. And the problem gets worse the more species you discover. Therefore, the only logical thing to do to ensure survival is to preemptively eliminate every intelligence you find. Story 11. 94% of our universe is forever out of reach. The Andromeda Galaxy is the only other galaxy in our universe close enough that we can theoretically travel to until it merges with the Milky Way. The Dark Forest Theory. The reason we can't find life is either because there is none, or that every alien out there knows not to broadcast themselves like we are, for fear of something lurking in space. In short, they know something we don't. Story 12. Space is so big, it's beyond human comprehension. The moon is 239,000 kilometers away. The sun is 98 million miles away. It's so far that it takes light, traveling at the speed of light, 8 minutes and 23 seconds to reach us. To think about how far it is, it takes 43 minutes for the sun's light to reach Jupiter. So if the sun disappeared, we wouldn't know for 8 minutes. And we'd still be in orbit for 8 minutes. Then, when the sunlight stopped, we'd be flung into the cold darkness of space. The most distant artificial object is the spacecraft Voyager 1, which, in November of 2021, is nearly 14.5 billion miles, 23 billion kilometers, from Earth. Voyager 1 and its twin Voyager 2 were launched 16 days apart in 1977, so an object traveling since the year Star Wars came out is only 14.5 billion miles from Earth. 45 years later, it takes light 25,800 years to reach the center of our Milky Way galaxy. In the observable universe, just what we can see, there are 200 billion galaxies. Astronomers believe that there are some 10 million superclusters in the observable universe. A supercluster is a large group of smaller galaxy clusters or galaxy groups. The Milky Way is part of the local group Galaxy Group, which in turn is part of the Virgo supercluster, which is part of the Laniakea supercluster. Humans can't even understand how far space is. It's so incomprehensibly large. Story 13. Space radiation is real, and those who talk about Mars and moon colonization don't seem to take that into account. If we do get to those places to live, those that do will have to build underground until structures that can protect against the radiation can be developed. People who go to and from Mars on the 9-month window when the planets are closest together are going to be showing signs of radiation sickness by the end of their journey. Another related fun fact is early astronauts had this phenomenon where they would see brief but very bright flashes of light with their eyes closed and had no explanation. Because it was so strange, no one wanted to say anything for fear they'd be labeled crazy. Then one day, someone casually mentioned it, and they all realized it happened to them all. The theory of what was happening was cosmic rays would fly into the optical nerve and irradiate it, causing a brief flash of light. The phenomenon is called cosmic ray visual phenomenon, or astronaut's eye. Apollo astronauts reported this happening as frequently as once every 3 minutes or so. Crazy, crazy stuff. Story 14. We will never reach its limits. Most of it we will never be able to see, even through telescopes, because of the expansion of it making the light move away at a certain point. If there are aliens out there, there's a good chance they are hostile, or have the ability to be hostile. And if we were to go and try to attack them, they could see us from very far away, and make so much technical advances in that time, it would look like apes fighting a Jedi. Story 15. One reason spaceships are so cramped is because in 0G, if an astronaut was in the middle of a room so large they couldn't reach a surface, they'd have little hope of moving themselves and may get completely stuck in place relative to the room. The only options would be trying to swim in air or throwing something like your shirt or shoes in the opposite direction to provide a nudge. The moral of the story is don't be naked in a large airless room in space. Story 16. FTL of any sort violates the laws of causality and creates a paradox, like being able to receive a message before it was sent, and thus is almost certainly impossible. This would also explain why we don't see any evidence of aliens flying around. It's a bit of a depressing realization, but the fundamental logic behind it is quite sound and irrefutable without a complete rework of everything we know about physics. That's not to say it's impossible, but it's a long odds. The truth is, FTL is likely impossible and nobody will ever get to fly from star to star in a single lifetime. Story 17. The heat death of the universe. Eventually, the universe will be a cold, dead place. Nothing anyone does will matter or be able to stop it. There is no hope. This is a nihilistic dream situation. The universe is expanding faster and faster. The light farthest from us is from galaxies moving away from us faster than the speed of light. You cannot move through space faster than the speed of light, but the universe expands in the vast spaces between galaxies. And if the distance is great enough, that means other galaxies are moving away from you faster than the speed of light. The only galaxies that are gravitationally tied to the Milky Way are in our local group. Eventually, all of these galaxies will merge. Then, all other galaxies will be moving away from us faster than the speed of light. Future civilizations and intelligent life will think the entire universe is one big galaxy and will have no idea about the rest of the planets. So this means they will not know about the Big Bang and a lot of fundamental physics. Eventually, supernovas will take too many heavy elements and no new stars can form. The red dwarfs will be the last stars. Then eventually, all stars in the universe will go out. The only remaining power sources will be black holes. Will advanced civilizations be able to harvest energy from black holes? If not, life will be over. Eventually, black holes will evaporate and cease to be. This is what made Stephen Hawking famous. His theory was proven not long after he died. If it had been proven while he was alive, he may have won a Nobel Prize. Eventually, there will be no power source left. Then the universe will expand faster and faster. Eventually, all matter will be ripped apart. There will be nothing left but fundamental particles in a cold, dead universe. No memory of humans, or Earth, or any galaxy. All life will cease to be. Story 18. Might be said somewhere else, but your blood can boil in space. The reason for this being that there is no air in space, meaning no atmospheric pressure on your bodily fluids. That leads to no heat being required to break the bonds that hold the liquid together, since the atmosphere on Earth is enough to force the liquids you see together. You can even test it on a small scale. The higher you go in elevation, the less time it takes for your water to boil, assuming the amount of heat you add over time stays the same. Story 19. A burst of electromagnetic radiation, known as a gamma ray burst, from millions of light years that lasted just 1 second, could deplete 70% of the Earth's ozone layer and heat it up by 4 degrees Celsius globally, and would cause a mass extinction from hundreds of thousands of trillions of kilometers away in just 1 second. Story 20. Strange matter. It's a hypothetical type of matter in which the arrangement of quirks in its elementary particles makes it the ideal type of matter. The disturbing part is that since strange matter is so stable and might just be the ideal state of matter, every other form of matter it touches will immediately be impressed by it and will rearrange its own quirks to become strange matter. That essentially means the complete annihilation of all matter in the universe to become a new, more ideal type. Now, strange matter is only possible in neutron star cores, and are essentially separated from the rest of the universe, unless 2 neutron stars collide and create a kilonova explosion, at which point the strange matter might get out and start to spread. Story 21. Just a small example of time. Voyager 1 is 14.5 billion miles away from Earth. It was launched in 1977 and is still working, and it is further than any other man-made object has ever been, way past our own solar system. But that is not the incredible part. Since it is still talking to us, it's so far away that when it talks to us, it takes 20.5 hours to get to us, and another 20.5 hours from us to get back to it, to tell it something. So it pretty much takes 2 days from when it tells us something and we tell it something. I mean, think about your phone. You can talk to people on the other side of the world and it's almost instant. How would it be if it took 10 minutes to send and receive something from them? So unless we find a better way to talk to each other, if we go into space and need help, the answer might not come back in time. Now that is disturbing. Story 22. There has been enough time in our galaxy's existence for an intelligent species like us to colonize the entire galaxy of habitable planets, millions of times over, with our best theories of technological advancement. The fact we haven't encountered them means either we are products of them, or there is a great firewall between intelligent species and its respective technological advancement that stops it from advancing. Either we are bound to our respective solar systems or local clusters, never able to leave because the laws of the universe will not allow it. We are that rare, or we end up destroying ourselves. Story 23. Some good facts here about black holes, but missing by far is my favorite one. According to a Kurzgesagt mini-doc on black holes, we're missing something massive, pun intended, about them. For starters, we've got a working theory for how black holes form, but there's a problem with it. The time that it would take means that the largest black holes in existence would be several times older than our entire universe. It gets worse. If our theories were correct, we would be finding black holes of all sizes up to the supermassive ones. But we're not. Instead, we've got black holes that we understand, a big gap, and the supermassive ones. This means we're missing something, and it's something big, about how black holes work and form. And that means we're missing either literal chunks of physics or that there's an even more ominous reason for supermassive black holes. From weaponized creations of vastly powerful beings to everything we know about the age of the universe is flawed. An actual astronomer who specializes in black holes could doubtlessly explain it better than I, and I might have missed a few details. But the data we have is kind of like finding baby alligators and fully grown alligators the size of a school bus, and nothing in between. Story 24. If you are flown into space and you aren't in a spacesuit when you exit the craft, you die in 3 different ways at the same time. Space is a vacuum. No air in space. You suffocate. Any heat in space immediately expands and moves outward from the source. And because of space's vast and infinite nature, there is no warmth in space. You freeze to death. This one's kinda optional, but if there's a solar system headed your way before you suffocate, your skin will burn, you will get cancer, your skin will flake off, you die of radiation poisoning. Scary stuff.